Until now, we have built our Spring Boot service and created Docker image, pushed it to our ECR. Now in this session, we will deploy the Docker image using ECS Fargate. So let's proceed. In AWS Console, search for Elastic Container Service or ECS. Click on Elastic Container Service, and here our first task is to create a cluster. So click on cluster, click create cluster, select this networking only, click next step, give a cluster name. We are not creating any new VPC for this cluster, so leave it as it is. It is good to create a tag over here, so you can create one tag. We are not enabling this CloudWatch Container Insights. Click on create. And it has created ECS cluster. Click on view cluster. And this is our cluster. Now our next task is create task definitions. Click on task definitions. Click on new task definition. Select this Fargate type because there are two launch types, Fargate and EC2. And in this tutorial, we will be using Fargate. You can see the quick difference between Fargate and EC2, which says that Fargate is based on task size, where EC2 is based on resource uses. Fargate requires network mode AWS VPC, where multiple network modes are available for EC2. Now click on next steps, give a task definition name, select a task role. I'm selecting a ECS task execution role. Our network mode is AWS VPC because we have selected the type as Fargate. The task execution role by default it is selected. Task memory, we have to select the task memory. I am selecting here 0.5 GB as minimum possible. And also tasks CPU. So it is 0.25. Now we have to add the container in this task definition. So click over add container. Here give a container name. Now it is asking for the image. It means when this container will be instantiated, then it will pull the image from an image repository. Now in this tutorial we are using ECR, Elastic Container Registry, as our Docker image repository. So we will be using that. If you are using your Docker Hub for your Docker image repository, then you can add that here. So let's go to our ECR repository. Search ECR and copy this URI from here. This is our ECR repository. Paste it over here, and we need the latest image. That's why I have added :latest. Now we are not adding any private repository authentication. That's why I am not enabling it. Now we have to define the memory limits. Soft limits, I am just defining it as 128, and you can add the hard limit as well. Now in port mapping, add 8181, as our Spring Boot app will be running on 8181 on the TCP protocol. That's fine. Scroll down. We are not adding any health check over here. Under environment, we are adding the CPU units as 128, and it is actually the number of CPU units to reserve for the container. Okay. Scroll down. We are not modifying anything. Just click on add. And we added one container over here. Now you have seen that our task memory and our task CPU allocation has been consumed. Now scroll down. We are not enabling app mesh integration or proxy configuration or fire lens integration. And we are just clicking over create. And it's showing that it has created successfully. View task definition. Now we have created our cluster and task definition. Let's go inside our cluster. Click on cluster. We have 0 task running. We have just created the task definitions. Now we have to create a service. Click on service. Select the launch type as Fargate. Task definition has been automatically populated. Fargate type. Platform version latest. Cluster is the selected one which we have just created. Add a service name over here. Number of tasks. It is actually the number of instantiation we want. Suppose in our case, I will add 2. I'm not changing minimum health percentage, maximum percentage. Now under deployment type is rolling update. Let it be. We are not doing blue-green deployment at this point of time. Let this enable ECS managed tags. Click on next step. Now here, select the cluster VPC. Here I am selecting our default VPC. If you have one custom VPC, definitely you can select it. Now I am selecting the subnets. Now, when you are selecting the subnet, remember when we created our application load balancer and selected the availability zones. During application load balancer creation, we selected B and D availability zones. So we should select B and D, means the same availability zones. The reason is, if we select different availability zones or the subnet over here, then application load balancer will be trying to reach in a subnet where we don't have the tasks, and the application load balancer will show unhealthy, and ultimately your application will not work. Okay, so we have selected subnet under availability zone B and D for the reason as we created application load balancer for availability zone B and D. Now security group, it is saying that by default it is trying to create a security group Spring 3618 just by name. So I'm clicking on edit, and here I am also adding one custom TCP role because our application will be running on port 8181. Click on save. Now scroll down. Here it is saying health check grace period requires a load balancer. Yes, we have load balancer created. So click on application load balancer and select the application load balancer. It has automatically selected because we have one load balancer only. Now container name port, which is showing 8181, and click on add to load balancer. Now select the listener port, which is 80 HTTP, production listener protocol HTTP, target group. This is the target group we created. Our target group protocol is HTTP, target type is IP, path pattern is / and health check path is /actuator/health. It has taken from our target group configuration. Now we are not enabling service discovery integration over here. Click on next step. We are keeping it as it is. We are not enabling anything for auto scaling. Click next step. This is the review page. Review it and click create service. And it started creating the service and completed successfully. Click on view service. Now under service in task, you see that there are 2 tasks showing because we created 2 replicas. We given the number 2 for 2 replicas. Okay, and it is showing the status is provisioning and desert status is of course running. So the provisioning will change to running in few minutes. At this moment, it is actually pulling the Docker image from ECR and deploying the Docker image. Let me do a refresh and it is showing it's running. Well, then let's go to our application load balancer. So search EC2, go to load balancer, check the target groups, whether it is healthy or failing anything. It's saying that unhealthy threshold, 2 consecutive health check failures. Go to click on targets. It's showing one instance is healthy and another is unhealthy. because the another is unhealthy because it is trying to complete the deployment of the Docker image. Now it is showing healthy. Perfect. Now let's go back to our load balancers. Copy this DNS name or the load balancer URL. Open a new tab in the browser and let's check our actuator health endpoint first. So it is our load balancer URL /actuator/health. Enter. And it's showing up. So our service is actually up. Now let me open our Spring Boot service code. Let's see what we have done in our Spring Boot service. So I am just opening the REST controller in our Spring Boot service. And in our controller, we have two methods, as I said before. One is get mapping, another is post mapping, which is get transaction and save. So now let me check quickly whether this get transaction is working or not. And as I said, that our Spring service will be connecting to DynamoDB and will fetching the record for this transaction ID what we will provide, the transaction ID which we will provide. So let's go to DynamoDB first. Let me show you the DynamoDB. Search for DynamoDB. I have one table created in DynamoDB called transaction. So I have just selected this table transaction, click on item, and you see that I have few records already. It is a dummy record just added. Okay, just click on one record and this is the transaction ID I am just copying. And let's go back to our Spring project, and it's saying that we have to pass this transaction ID and it will fetch the corresponding records, which is these are the records, amount, date, and transaction number, like this. Okay, so in our load balancer URL, we will give this transaction service. So which is our transaction service? That is transaction. Okay, so our URL will be our application load balancer URL /transaction/ the transaction ID we have copied. So let's enter, and it has perfectly fetched the transaction details by this transaction ID. So it means that we were able to successfully deploy our Spring Boot service using ECS Fargate, and our Spring Boot service is able to connect to DynamoDB and fetch data from there. So I am just giving a quick revision of what we have done in this session. Is that in Elastic Container Service, we created one cluster, one task definition, and service. We created this cluster. Under cluster, we created the task definition and created this service. And if I go under the service, you see that the tasks are running over here. Now, if I click over this task, it will show you the task details image. This is the image it has taken from the ECR, where we pushed our image after build using code build. Now let me show you one thing. What if I delete or stop all these tasks? Let me stop all these tasks and wait a bit. And you see the new set of 2 tasks have been generated automatically. It means that suppose your one task went down, it will automatically provision the next task, and always it will maintain 2 tasks because we given the number 2 that the number of instance we need to. You can add there multiple numbers like 5, 10, 20 like this. So again it is showing provisioning. If I just give a refresh, it is showing running. Click on the tab stopped and you will find the stopped task with their reason. It says that stopped was stopped by user. So if your task was stopped by user, it will show like that. If your task was stopped by any error, then also it will show. So click over this task and you will get the reason over here. So till now, we have seen that how we were able to deploy our Spring Boot service using ECS Fargate. Now in next session, we will see how can we create a code pipeline to automate the whole process starting from code commit to code deployment. Let's proceed to next session.